In order to find the critical values of f of x equals e to the 1 minus x squared, first thing we need to do is take the first derivative using the chain rule. The derivative of e to the u is e to the u times du dx, which in this case is negative 2x. And we need to find all the spots where this is undefined or 0. E to the 1 minus x squared is defined everywhere, so is negative 2x. So the product is defined everywhere, so this will only equal 0 when negative 2x equals 0, because e to the 1 minus x squared will always be positive. So we only have one critical value, and that is at x equals 0. Now we need to classify it as a relative max or a relative min. We're going to do that using the first derivative test. So I'm going to make a number line. I only have one place where the first derivative is 0 or undefined, which is 0. So I'll test the negative value. Let's go with negative 1. Negative 1 squared is 1. 1 minus 1 is 0. E to the 0 is 1. Negative 2 times negative 1 is positive 2. So it is positive on that interval. Now I'll try a positive number. I'll try 1. 1 squared is 1. 1 minus 1 is 0. E to the 0 is 1. Negative 2 times 1 is negative 2. And 1 times negative 2 is negative. So since our function goes from increasing because of a positive derivative to 0 to decreasing, I know that at x equals 0 there is a relative maximum. Alright, for the second part, we are calculating the second derivative at x equals 0 because that is our critical value. So I need to take the second derivative of negative 2x times e to the 1 minus x squared. I'm going to do that using the product rule. Oops. It's f prime of x, so f double prime of x. This will be my u, and then e to the 1 minus x squared will be my v. So I'll take u times the derivative of v, which is e to the 1 minus x squared times negative 2x. Then I'll add the derivative of u, which is negative 2, times v, which is e to the 1 minus x squared. Because this is multiplication, I can use the commutative property of multiplication to make this 4x squared e to the 1 minus x squared minus 2 e to the 1 minus x squared with a little factoring. This is my second derivative. This part of the problem just asks me to evaluate f double prime of my critical values, of which I only have one. So that would be f double prime of 0, which in this case will be 4 times 0, which is 0, minus 2, so negative 2, times e to the 1 minus 0 squared, which is e to the 1. So I get negative 2e. Now, because at my critical value my second derivative is negative, I know that my critical value, it is concave down, which confirms what we did with the first derivative test, which is that at x equals 0 we have a relative maximum. And then the last part says find any points of inflection. Well, in the previous portion we found the second derivative. I'm going to write it in factored form, which is 4x squared minus 2 times e to the 1 minus x squared. This factor is never 0. This factor will be 0 when x equals plus or minus the square root of 1/2 or plus or minus root 2 over 2. So this is where the second derivative is 0. To make sure that it's a point of inflection, I need to make sure that it changes sign. So I'm going to make another number line. This time I'm going to use the values where the second derivative is 0. Square root of 2 over 2 is about 0.707, so I'm going to choose a value of -1 to test this interval, 0 to test this interval, and 1 to test that interval. I'm going to substitute into my second derivative. -1 squared is 1, times 4 is 4. 4 minus 2 is 2. So this is positive. E to the 1 minus x squared is also always positive. So that is positive. At 0, I get 4 times 0 minus 2, which is -2. That's negative. E to the 1 minus x squared is always positive, so a negative times a positive is a negative. So I know that this is a point of inflection. And then lastly 1. 4 times 1 minus 2 is 2. That's positive, times something that's positive. So this is positive. So I know I have 2 points of inflection when x is negative root 2 over 2 and when x is positive root 2 over 2. But I do need the points, so I need the y coordinates as well. So the first point is negative root 2 over 2, and then I'm going to substitute that value back into f of x, which would be e to the 1/2 power, or square root of e. And then root 2 over 2, and when I substitute that into f of x, root 2 over 2 squared is 2/4, which is 1/2. 1 minus a half is a half. So I also get e to the 1/2. So these are my 2 points of inflection.